Hello. So in this question, we have to solve for the concentration of X, and it gives us some information. So first, let's write out the chemical equation for this formula. So it says XOH2, and we have to figure out what X and M are eventually. And this is titrated with a dilute nitric solution. So nitric acid is HNO3. And when this happens, it's going to produce H2O plus whatever M is. And M, you know that it has a charge of 2 minus because OH usually has a charge of 1 minus. So it usually has a charge of 1 minus. This has to have a charge of 2 plus just because it already gave us a formula here for 2. H usually has a charge of 1 plus, NO3 usually has a charge of 1 minus. Therefore, when you cross NO3 and M, you should get MNO3 2. Now you're going to have to balance everything. So to balance everything, we need to put a 2 over here because there's 2 NO3s. And you also need to put a 2 here to balance the H2O, and everything else now should be balanced. Okay, great. So now let's see what we have. So it gives us X solution of M hydroxide. So it says that it's 3.7 grams per decimeter cubed. Okay, that's fine. Then it also says that the acid, the concentration, so C for concentration, is 6.3 grams per decimeter cubed. That's fine. It says that it also gives us the volume. So the volume it gives us is 50 centimeters cubed. 50 centimeters cubed is the same as 50 milliliters, and 50 milliliters is the same as 0.05 liters. So that's how I got it down here. So from here, you can solve for the moles. So concentration equals N over V. So now we need to find the moles of HNO3. It already gave us the grams. So what we can do here is we can just figure out the moles of HNO3. So from HNO3, if you add all of this up, HNO3, H usually has a molar mass of 1, NO3 is 14, and the oxygen usually is 16 times 3. If we add this all together, so 1 plus 14 plus 16 times 3, you get approximately 63 grams per mole. So to solve for the moles, N equals 6.3 divided by 63. So now that we determined that the moles of HNO3 is 0.1, we're going to figure out the moles of MOH2. So based on our calculations from earlier, from the balanced chemical equation, it's a 1:2 ratio, which means that it's going to be X to 0.1. When you cross multiply this, you should get X equals to 0.05. So this means that now we have the moles is 0.05 moles of MOH2. From here, we are able to solve for A. So this means that X equals 0.05. Great. So next it says that we have to find the molecular mass of X. So what you do is you use the formula N equals mass over molar mass. 0.05 equals 3.7 over molar mass. So when you do this, you're going to get molar mass equals 74. So now the relative molar mass of X is going to be 74 grams per mole. And now we need the relative atomic mass of M. So from here, we know that MOH2, the whole thing is equal to 74. And what we can do is we can subtract it from this part here. So 74 minus, so oxygen, so OH, oxygen is usually 16, hydrogen is usually 1, so 17 times 2 is 34 minus 34. So 74 minus 34 gives us a value of 40. So the relative atomic mass of M should be 40. And this should be your final answer.